No, I think what you're saying is that the key point there is that you're not when you have an emergent phenomena, it's not as if it's somehow second best and could be reduced to something more fundamental. It becomes a new fundamental level, at which is the right way of understanding something. And do you think there's there's a difference there between a kind of epistemological emergence, right? So you understand magnetism best in this collective way. You don't really understand it very well if you try to focus too much on the atoms. So in some, that's epistemological emergence. Emergence as a right way of knowing, understanding something. Do you think there could also be a kind of ontological emergence, so that something truly is new at a new level?
Well, philosophers discuss this a lot and make these distinctions between epistemological and ontological emergence. I actually rather feel that the distinction is a false one. Okay. And I think it's because I used the term elements of reality earlier on, yeah, with some intentionality, because I think actually we are talking about reality. In science, there is always this battle between what we perceive, looking through a glass darkly, and what is actually there. And in science, I think we have a strong view that we are making statements about reality as best we can, and there is always the as best we can, because there's a provisionality about everything that we do. But I think these particular phenomena, these emergent phenomena, have an element of reality. They have an ontological status. But there is also an epistemological dimension, because it's based on what we can perceive. And we as human beings, we actually have a limit, and that limit is in terms of the size of the human brain. And at upper level, you know, the computing resource that we could use to study the world, even if we augmented our human brains by computers, is still limited by the number of particles in the universe. And if you work out the computational capacity of that, that's still limited. And thermodynamic problems, the kind of things that we're dealing with, have a lot of large numbers in them, factorial. So in fact, there isn't enough physical resource in the universe to study some of these things in the reductionist way. So there are actually, I think, physical limits to the way in which we perceive the universe.
So this brings us on to a kind of Laplace's demon in some sense, right? So the ultimate reductionist would be Laplace's demon, who can see every single atom moving and therefore calculate where it's all going. And what you're saying is the universe doesn't have enough computational power in it to do this.
Exactly. So I think that exercises the Laplace's demon in much the same way that in information theory we've exercised the Maxwell demon. Exactly. And it comes from the same root. I think it's an information limit.
Yeah. So that's quite fascinating, because on the other hand, although I can't calculate it, it is true that the universe is moving forward. So something is calculating. So how does that work?
Well, those microscopic laws are operating, yeah, but I think a lot of it is to do with our ability to follow it. Yeah. And I think this is very important, because in condensed matter physics, thermodynamics is one of the key things that we think about. Yeah. And one of the notions in thermodynamics is of course entropy. Yeah. Now I think entropy, people debate this, but I think entropy does have a very strong subjectivist dimension to it. Partly because, you know, we can look at the air molecules in this room and work out their entropy. And their entropy is essentially due to the fact that we don't know where they are. We don't know the microstates. Yeah. But if we could have a Laplace's demon that could look at the air molecules in this room and know all the microstates, yeah, then the entropy would have disappeared. Yeah. There would be no entropy, because you'd know exactly which state the system is in. Yeah. Now I think Laplace's demon, for various obvious reasons, can't operate. Yeah. But it does kind of emphasize the fact that entropy is in the mind of the beholder. Yeah. I think a lot of physical quantities are like that.